Hello, Physics Nation. My name is Nate Larmond, and I'd like to do a Khan Academy problem from the set called Calculating Work from Force versus Position Graphs. So here's our force versus position graphs. We have force measured in newtons and position measured in meters. And I almost got caught in a trap. Notice the symmetry. There is as much negative work as positive work. So I was about to put in 0 and get my happy confetti. No. Watch the interval. Khan will slice up one graph into a bunch of different problems. So just be careful. They want to know the work done. Let's see. The net horizontal force on a box as a function of horizontal position is shown below. Okay, so we're pushing a box to the left. Is that to the left on your screen? No, that's to the right on your screen. So we're pushing a box to the left with a decreasing force. This is the maximum force. Okay, so negative 40 newtons drops to, well, this book is at the origin and then it moves, hang on, and then this book is at the origin and then it moves to the right 4 meters while there's a negative force acting on it. Let's see. So this is in fact the interval. And here's the trick. We go from negative 40 to negative 20, but you can pretend that you stay at negative 30 the entire time. So that's the average force. Let's see if I can write this. The average force is, as long as the force changes linearly or at a constant rate, is negative 40 plus negative 20 all divided by 2. So the same way we find the average velocity by doing v initial plus v final divided by 2, you can find the average force by doing the initial force plus the final force all divided by 2. This is negative 60 divided by 2 is negative 30, obviously, and so the work is force times distance, or excuse me, force dot distance, FD cosine of theta. In this case, I think the force is anti-parallel. So like I said, I'm moving positive, but the force is backwards, okay? So I'm moving in the positive direction, but the force is backwards. That means negative work is done. We are robbing energy from this system. The average force is negative 30. And the displacement right there is 4 meters. So that's negative 120 joules, or the area underneath our rectangle. I don't know. Let's see if we can get the happy confetti here. What did I just say? Negative 120? Yeah. Hey, thanks for watching. See you in the next video. Well, I don't know. Maybe the next one's fun. Hang on. Yeah, so this is actually the question a student asked me, and we're going to do the same trick, 0 to 6, okay? So this is the graph. The student videos are great. They're uploading videos and asking me questions and presenting their problems. Anyway, finding the average force takes a little bit of practice, so we are starting at 10 newtons right here. That's the force. Now the motion is positive and the force is positive. Hang on. So if they're in the same direction, you do positive work. So we're dumping energy into the system, not robbing it out. Negative work drops the energy of a system. All right. Yeah, so we start at 10 newtons and we end at 40. Right in between 10 and 40 is 25. All right, so the trick is you find the average force. F bar is the fancy way to say average. Because the force changes in a nice linear constant manner, you can do this. And what's 25 times 6? 150, I think. All right, so we do 25, the average force multiplied by 6. That's the work done. Hang on, work. This is horribly sloppy. pardon my sloppiness. Work equals force times distance. Can I clean this up? No, not really. Okay. Anyway, I think it's 150 joules. You ready for the happy confetti? Everybody loves Khan Academy. You ready? Come on, happy confetti. Hey! And that's enough. Thanks for watching. See you in the next video.